In today's episode, we have a very special guest. He spent 40 years at Ford working on their iconic car, the Mustang, and now a professor at the University of Michigan. Today in the garage, Art Hyde, Mr. Mustang. Let's go. Welcome to the garage. We're recording live from Autotech Detroit, and we're so pleased today to welcome a special guest. Art Hyde was 40 years at Ford working in engineering across the company, but especially with their iconic Mustang brand. Now he's a professor at the University of Michigan in Automotive Engineering. Art Hyde, welcome to the garage.
Thank you very much, John. It's nice to be here.
So we always like to get to know our guests, and usually later in the introduction, we like them to tell us a story, a unique story about them. But for you, the unique story we need to hear from you is no question. You have to tell us about the first time you saw the Mustang. I think it was 1964, is that right?
1964.
So
yeah.
you got to tell us that story, and that'll be our fun fact of the day about you.
So my father was raised in New York City, but we were living in Virginia. And so we would go to New York on a pretty regular basis every year. And one year he took us to the 64 World's Fair that's in Flushing Meadows. And all the lines were really long. So each person in the family, there was 5 kids. We were directed to stand in line at one of the places. Luckily, I didn't get the Disney one, which is It's a Small World, sort of welled into your mind. I got the Ford one because that's what I wanted. And so I was standing in line for probably a couple hours, and there was a Mustang over top of a pool that they had. And just looking at it, and I realized, I am going to run this business. I'm going to do something with this. From that point, 9 years old, I have no idea where that came from. I always loved cars. I would sit in the front porch and watch cars go by. I could tell their motors and motor noises and stuff like that. But the Mustang became a special thing in my life.
And it's such an amazing story. And it's a true story that at 9 years old, you said, I'm going to run this brand. I'm going to run this product. It's an unbelievable story.
And I had no idea what that meant.
And I want to get into the story of how you actually made that. You almost manifested that and made it happen. I always tell our guests that I want to tell a story to bond with them a little bit. And since you said you were 9 years old, I got to tell you my fun fact about 9 years old. When I was 9 years old, I went to this trade show in downtown Pittsburgh, where I was from Pittsburgh. And it was a computing trade show when computers were mainframes. And I touched a mainframe at 9 years old, the console, and I never looked back. And I started, kind of messing with the thing. And the guy came. One of the guys came over to kind of get this kid off this thing, and the other guy said, "No, let him go. He knows what he's doing." And I never looked back.
That's fantastic.
So there's my story for you
today. It's almost the same story.
It is. It really is.
Yeah.
So now tell us about the journey from that point on until you actually had a career at Ford, because it's an equally interesting story. How did you develop your career to that point?
Well, first off, to make money during college, and I became a mechanic. So during high school and college, I was a mechanic. So I had done that, and I went to a college, unfortunately, that Ford stopped recruiting at because the president of GM had gone to there, and GM was really heavily recruiting from that school. I didn't want to work for GM. I only applied to Ford. I wrote a whole pile of letters over a year-long period, became a general pain to the guy that was the vice president of product development. Back then, you could call up the operator and say, who's the head of product development? And they would give you that guy, or who's the head of Mustang? They'd give you could talk to those people. And, but I talked to the secretaries and wrote letters, and eventually they brought me out. And luckily, I was able to get a job. And but I set my whole career up on being what I knew the title. I didn't know what the title was, the Chief Engineer of Mustang. So I, talked to other chiefs and find out, what do you have to know? What are the things you need to be good at? What are the issues? And so I built my career plan around touching all those bases, and literally in a progressive way, so that I was ready for each successive steps. But it was a big plan, I'll call it.
So you had a 20-year career in Ford and finally realized your ambition of being Chief Engineer of Mustang.
Right.
So during that time when you were chief, what are some of the things you did to revitalize this iconic brand?
Well, the main problem that kept eating away at me is here we have this great brand everybody knows of, but we were losing money on all the vehicles. And what's wrong with this picture? And one of the things I realized was that the average price people were paying for a Mustang was actually lower than the Focus.
Incredible.
And because marketing thought that the customer was the dealer. And my view was no, the actual good person who buys the vehicle, because that's where the cash comes from. They're the people we have to focus on. And so, I had all my engineers on social media in 1999, and we were doing customer connection type clinics around the country to understand what's behind Mustang and things, because we can't rely on the marketing guys just to do and sell it through advertising. We want to sell it through, you see it, you know what it is what it is, and it's the instant vacation that you're searching for. It's something to aspire to. But Mustang's attainable. That's the big difference, say that versus Porsche.
And you helped to build these affinity groups and the kind of Mustang Club. I'm going to get that name wrong. Is that right?
Yeah. Mustang already had a fairly big club when we started. But I actually joined the board of directors of the Mustang Club of America and helped them get their act together. And so we grew it to 20,000 people while I was there. And also we found that we had more members of the Mustang Club of America in Sweden than we did in California. And we weren't selling any cars there. So I started on a campaign saying, what's wrong with Ford? I mean, we got to be able to sell this thing in Europe. And the Europeans wanted it. But in the end, the Europeans also was sort of the way the business worked out. It wasn't advantageous for Ford Europe in some sense, because if there was a revenue that came in, North America got the profit. And they just had to pay for the cost of parts and service, and that's not the right way to run the business. So that has since been fixed. But I had to drive a lot of that stuff. It was that, and also I had to drive a mass customization, because the Mustang is got to be, it's an individual thing. It's freedom of expression. It's self actualization. It's a way to say who you are, and just sort of stake out your claim that, don't mess with me. And, more than half the Mustangs, when I was chief of Mustang, more than half the Mustangs were bought by women. And when we went and talked to women, why are you buying this car, and why aren't you buying Camaros? Because they weren't buying Camaros. We found out the reasons, and a lot of it was that, Mustang was sort of the classic, but also we designed it so it's accessible to women. They could see out of it. They could keep their shoes, because they have the shoes of different colors. And they can put stuff in it. Their purse is a lot easier than a Mustang, but we purposely designed it. None of that was a mistake or an accident.
And you also said you deliberately released the specifications of some of the parts to a third party so they could make customized parts.
So I led a team that we did exactly that, so that we had Mustang, we call it the Mustang 7. So there were 7 approved aftermarket fitters, so that when they sold a car, the customers didn't know whether it was designed by Shelby America or Celine or what have you. They just knew it was a Ford. And so if there was a problem with their parts, it came back on us. And so we wanted to make sure they could help improve their quality. And we had to work with them to understand how it is you measure quality, what does quality mean, how do you verify that quality. And so it was a pretty big effort to do that, but it was worth it.
You also did some really interesting partnerships. The famous movie Bullitt had an iconic Mustang in the movie.
Yeah.
And I think you did a program to kind of help. You sold a model that was like the model in the movie, right?
Yeah. It was. So one time we were in the design studio, and one of the stylists said, we needed a new wheel, because you make a lot of profit off of wheels. So this guy came in with a new wheel, and the wheel was exactly the same as the wheel on the Mustang Bullitt in the movie Bullitt. It's a truck thrust wheel, we call it. And so we were, after the meeting where we approved it, said, we got to do the rest of the car. And so one of our designers just took on himself and made a sort of, if we were to do a Bullitt, here's what it would be. And we showed it at the Los Angeles Auto Show, really underground. I mean, I think the head of design knew about it. A couple of us knew about it, but it was very down on the down low. Nobody was involved, because if I had let it be widely known, they would have stopped me. And so, we got into the LA Auto Show, and the thing took off.
Wow.
And so that was for 2001.
Yeah.
And we sold a time build of 5,400 units, I believe it was, and those vehicles were more profitable than the rest of the vehicle line. And also, they had 10% higher customer satisfaction, which was another big issue because the satisfaction at that time was not good because the quality wasn't good.
That's fantastic. And I know you even went so far as to tune the exhaust sound to match the movie.
Yeah, we did. You do it like a Winwood. It's just like a Woodwind. And so, we looked at the different speed load points and tuned it. And then when we got out to San Francisco for the unveiling, we had the actual stunt driver that drove in the movie because
Nice.
they didn't let Steve McQueen drive in the movie, contrary to popular belief. He wrecked on the first day, one of the cars. And so he didn't drive for the rest of the movie. And he said, "You're crazy because that exhaust sound was not the Mustang. That was Richard Petty's NASCAR stalker. It was actually a Chrysler Hemi engine. If we had known that, I don't know that we would have done it. But it's great, and it really set a, I think exhaust sound is part of the Mustang thing, is one of the Mustang things where it wasn't really before.
So, moving a little closer to the topic of the garage, we talk a lot about vehicle software and really advanced vehicle technology. One of the things you did later in your career at Ford, I think, is very relevant to what we're talking about today. And you rolled out a program called GDPS, and I hope you could tell us about that.
Yeah, the Global Product Development System,
GPDS.
GPDS. I helped create the engineering part, and then I ran the entire enterprise across the 9 global engineering centers to execute it. And it was the steps and sequences of processes and disciplines to execute a vehicle. And so in that role, I had to approve every vehicle program in all of our engineering centers through every milestone, which the milestones are roughly 6 months apart. So the idea here is we want to get the engineers so we can be repeatable, delivering quality on time. It gets very expensive if you start elongating programs and delaying them, particularly if it's an unscheduled delay. So that's why, when we were talking and I was looking at your podcasts, it really struck me that, one of the big issues that we had, we did really well reducing time, improving quality. And then all of a sudden, we weren't doing so well. And what was going on? Well, a lot of it was going on is trying to make the mechatronics system of the car work. And it's whenever a new technology comes in, it's got to be really digested by the organization and understood by the organization. And you have to have, I'll call it pretty clear disciplines associated with executing, because this is not la-la land. In the auto industry, our margins are between 5 and 10%.
Right.
So it's not like we have a lot of margin to play with. We don't.
Right.
And so we can't afford to make a mistake. We
Right.
can't act like Apple acts in this sense.
Well, I'm going to touch on that. You use this concept of mechatronics you mentioned. I think that's an interesting name. I haven't heard that said before. But I think by that you mean the intersection of hardware and software to make this effectively giant robot, in a way, operate. Tell us about that intersection and how you saw that towards the end of your career.
Well, it started coming in about 10 years before I retired in 17. I mean, in a big way. We would look at hardware and we would do what's called a failure mode effect analysis. And you look at all the ways that this part would fail, right?
Right.
The problem with software is it's got so many interactions. You can't do an FMEA. Reasonably speaking, it would be as thick as a book.
Right.
And so the question is, what are the important ones to go after? And nobody can really answer that question because you don't really understand the duty cycle and you don't really understand the useful life requirements. And so it's a real challenge. And if you leave it up to an engineer, they'll keep testing and testing and testing and testing, and then they'll still miss something.
Right.
And then we get to launch and we have to delay the launch, and that's expensive. So that's been a challenge.
So, I mean, this is a perfect segue, I think, into software-defined vehicles. So I think if you, in my opinion, probably almost every car you worked on was what we would call a hardware-defined vehicle, which is, a box has a specific function and has software in it, but it's narrowed to that specific function. As we look forward to software-defined vehicles, being that you've been around for such a long time, I might assume that you would be very much in favor of that model, but when we talked, your perspective was very different. I'd love to hear your perspective on the future of SDV.
Well, no, I think the SDV will help the OEMs. It will help the customers. Who wouldn't want that? The question is how. I think the SDV is a great thing to improve value and satisfaction and sustainability of the business. And so I'm a strong proponent of it.
Because I was in a session just yesterday, and I think you hear very different perspectives. I think you hear some perspectives of people, and just the keynote earlier this morning was saying there's a number of companies that are very eagerly all in on software, all in on, for example, electrification, and others that are, I think, resisting it and digging their heels in. But it seems to me that the shift to SDVs is inevitable.
It's inevitable. But there's always going to be fear. There's going to be early adopters, and then others will come on later. That's natural. We see that with electric vehicles now, right? That's a little different than software-defined vehicle. But some people buy it, and they love that. But some people say, I'm worried about the range, right? And the infrastructure. This isn't California anymore. We don't have all the fast chargers you have.
It's true. So, but coming back to software, I mean, I think as we see the ability to bring the innovations from other industries into vehicles, our perspective is that the potential to simplify the vehicles, and indeed there's some new complexity, but there's also some new simplification that comes out of that, is very compelling.
It is.
And what are some of the areas you think are the most valuable?
Well, first off, just getting rid of the number of processors. We had so many processors, and it was funny during the pandemic, and we had the chip shortage. We didn't even know how many chips there were on the vehicle. So a very good friend of mine was leading that effort to figure out for Ford, and we didn't even know what the chips were. We go and ask our tier ones, and they say, we don't know where those chips come from. And it took a long time to get his arms around it. And he did a hell of a good job, but in the end, that's money. And when you're dealing with a 5 or 10% margin,
right,
you can't afford to waste anything. I mean, in the auto industry,
right,
we kill for a quarter.
Right.
And which might be a little different than some other industries. But it's important that we can get that integration, but also I think the ability to add new features,
right,
is really very compelling.
Right.
People want that. They expect that now because of their phones, right?
Right.
The smartphone has changed lots of things.
That's right.
Right. But the cars are not ruled by Ohm's law. They're ruled by Newton's law. And so we have to do that in a way that the users benefit.
Right.
And cars, one way or another, they have to propel you.
Right.
And they have to protect you.
Right.
And the features are all nice and good, but if you don't propel and you don't protect,
right,
and I mean over the lifetime of the vehicle, then you're not doing your job.
Yeah, it's interesting because I think there's a fear. You said that there's these, laggards and so on. I think there's a fear that, oh God, software-defined vehicles will be less safe. Oh, they'll be less reliable. The reality is they bring the opportunities to be, in some sense, more safe and more understood. A lot of the validation approaches that we do today in other industries that you can bring to the table, I think can benefit the automotive development cycle. We're seeing a lot of compression of design cycle times, certainly from Asia. They're really compressing the design cycles, and we think software is one way that we can do that across the industry.
But we have to really think about how do we systematize it.
Right.
So the average person, because right now, I know all engineers think they're the smartest ones and they have the hardest job and all that kind of stuff. But in the end, we need the average person who can execute this thing,
right,
and on a repeatable way.
Right.
And that's not easy to do. It's not easy to do.
There's no doubt that this is causing a change in the design methodology. It's causing more parts of the company to need to understand software than did before.
Yes. But also, I think, you talked about the tools. There are a lot of great tools that are out there for software, and there's a lot of great tools out there for hardware.
Right.
But I don't know that we've actually worked very hard on the integration of those things.
Right.
And that's where my passion is right now.
Right.
Is to figure out how to get those to the simulation, the virtual cycles to line up.
Right.
Now, Formula One is doing a lot of this kind of stuff because they have to, because they don't get track time anymore.
Right.
And the auto industry can do that too. And ultimately, those are the ways we're going to reduce time. Those are the ways we're going to reduce, improve quality.
So I maybe shift gears and let's talk about vehicle architecture, because the historical vehicle architecture, as we said, was very distributed with all these boxes, 150 boxes in high-end vehicles. But as we move forward to the new future architectures, I don't think there is a single winner, and I think my view is there's a journey. What's your take on how vehicle architecture will evolve?
Well, I'm on the same view that it's a journey. There's trade-offs right here, right? I mean, ideally speaking, you'd like to have as centralized processing as you can get, because you can get rid of the chips, right? Memory chips as well as processing chips. But in the end, we can't afford to have these vehicles shipped out with lots of extra memory and processing capability. We can for maybe low volume vehicles or special one-offs or something like that. But ongoing, we have to optimize that.
Yeah.
And so that's why I think they'll be searching around. Some vehicles without a lot of options, you can do more central.
Right.
Vehicles that are like, I'll just take the Escape. We built it all over the world. Probably 14 plants build the Escape all over the world. And there's tons of different versions. And Southeast Asia ones that don't have air conditioning and heating.
Right.
And ones that are here with ABS and a self-driving ADAS type technologies. And we have to come up with architectures that work in both those cases, and not just work cost-wise, but also the verification.
Right.
Because you almost have to build up the functions and then integrate them.
Right.
But with software, it's not that simple.
Right.
Because there's so many interactions between the features.
Right.
And you don't want to have unique code if you can avoid it for those kernels.
Right.
So the containerized idea is something that I think has got a lot of potential. The regional approach has got a lot of potential.
Right.
But I'm on with you that this is a journey. I don't know what the solution is, and I don't know there'll be one size fits all.
And we were talking earlier, and you mentioned that it's also counterintuitive, because one might think, oh, well, just putting in a central computer, if you could do that, which maybe we're not there yet, but if you could do that, that would be just a great answer. But there's also physical constraints in the vehicle that make that challenging as well.
Yeah. Well, first off, the box is big.
Right.
The cooling for that box is hard, and the wiring is a big issue in the car business, because you can't bend the wires very easily, so it's bad for ergonomics for the workers.
Right.
And it also takes up a lot of space too. And a lot of our warranty is through non-connects and wires getting chafed and stuff like that, right? So we got to come up with what's the right balance. And I'm sure that there'll be, using multiplexing is going to be part of the solution. And we'll see. So that's zonal in some sense.
Yeah, that's right. That's what I was going to say. We see zonal architecture as a very sensible evolutionary step.
Yeah.
Especially as companies are looking to shift towards automotive Ethernet, and as opposed to direct connect, because as you say, these giant wire bundles that are like the size of an umbilical cord, it's impossible to bend. If you could go to a multiplex, multi-use cable, the ability to run those wires significantly lightens the vehicle, but also reduces assembly costs as well. And so it's a multi-win-win-win. And
the wire itself is expensive.
Right. Yeah, copper prices are crazy. So you mentioned earlier about the importance of managing cost. And I think sometimes those of us with a computing background think that we should build in for future-proof applications and things like building in upgrades and OTA for new features. But that's a more complicated trade-off because of the tight margins.
Yeah, right. So we can't really afford to put in extra memories and extra processing capability. And also, we do have to make sure that we can prove out all the features before they're released. And sometimes it takes time, and a lot of times it's sort of evolving, right? What you could do with this system, you don't actually understand all the capabilities at the time you're designing it.
Right.
And so that evolution, we have to have it be controlled.
Right.
So that the vehicle will be safe to operate and over its lifetime, and will meet what's required. But the upgradability is one of the great things about software-defined vehicles.
Right.
And so we don't want to lose that rabbit.
Right.
But we just got to make sure that we're not putting people at risk.
Right.
And that we are being responsible in our business dealings as well.
Yeah, I often say that we need to design for the applications and features we don't know about.
Yeah.
So we do need to build in the capabilities to add those in. That's one of the reasons we work on things like networking, being able to provision services that weren't there at the beginning, while at the same time maintaining the safety and validation you talked about.
Yeah. So when we design a vehicle, we always think about what are the other versions of this vehicle that we haven't yet thought about.
Right.
So if I take the Escape as a good example, we were delaying that vehicle out in 2016, but we knew at that time that platform was going to be a Focus, it was going to be an Escape, it was going to be a Bronco Sport. We knew it was going to be a large sedan, which was in China, and the pickup truck, the Maverick.
Right.
So we knew about all those. Now, was management aligned around all those things? Did we have business plans with those things? No. But we knew that that's where the market was going.
Right.
And so we designed the vehicle so it was capable
Right.
to do that using modular techniques.
Right.
And I think we have to think through like that. So you do have to look in the crystal ball, but understand that the crystal ball changes. And so nobody can predict
Right.
the way it's going to work.
Right.
So you want to cover as many bases as you can.
Right.
And then the ones that don't end up working, like we're not selling Focus in the US. So we're missing that one piece.
Right.
But we got the Maverick, which nobody thought we were going to get at
And
that
it's very
point.
successful, I think.
And that's
yeah.
been very successful. Yeah.
So you're talking about modularity, and I think you mean modularity in hardware, but I think that same modularity extends to software as well.
Yeah, absolutely. But we have to think it through as an integrated
Right.
It's an integrated thing. And there's a lot of, who owns the software for those features and how do you integrate it? So a lot of the things that you're in your other podcast, which I really enjoy your podcast, was
driving innovation. Yeah.
Well, so you need collaboration, you need standards. We those things have to be put in place to realize what we're talking about here.
So we've spent our time talking about your background at Ford, but today you're a professor at University of Michigan, dealing with the next generation of automotive engineers. What do you see, and what are some of the interesting things you're doing at Michigan?
Well, right now we're setting up an electric vehicle center, and so I'm heavily involved with that. And we have a lot of I'll call it internal combustion research going on with alternative fuels,
right?
So non-carbon based fuels. So there's a lot going on actually in the university. The other thing is in my group, I'm sort of the main guy for vehicle dynamics at the university in many ways. And so I get involved with a lot of these groups, but I think the one that I'm really trying to work it up, but it's hard to find experts, is the software-defined vehicle.
Really?
I want to do a course on how do you do a software-defined vehicle? How do you execute it? How do you architect it?
Right.
I have a course right now on how do you architect in a traditional way, but between you and me, I know that that's sort of like looking in the rearview mirror.
That's right.
And you're looking at the next 5 years. I'm looking out 30 years. I'm not looking out 5 years.
Yeah, we're in such a rapid phase of change right now. This cloud native design of designing in the cloud, deploying the vehicle, both from a validation and even a deployment and operational phase, it's going to change everything and for the better, but it's a journey.
And we have to figure out how to get the infrastructure and the verification methods and improve reliability. That's the issue.
We've got some University of Michigan grads at Sonatas, and they're great teammates.
Go Blue.
Yeah, thank you. And so are you people that come to Michigan, are they excited to be in the automotive industry? Is it becoming sexy again, I guess?
I don't know if it's as sexy as it used to be honest with you, but people are very excited about it though.
My experience is, and there's a number of design centers from pretty much every OEM in the Bay Area where Sonatas is based. And it's so interesting to see so much innovation and different kinds of innovation across the OEMs in the Bay Area. And so I think that's exciting.
Well, the stuff that's going on here is even more exciting, I think, because we're dealing more with the basics of the vehicle.
Right.
And I think that it's a really big system. It's important for the country. It's important for the world.
Yeah.
And so I personally think the auto industry is one of the really linchpin industries for the entire country and for most of the industrial world.
I think so, and I know that we're in this journey through EVs right now, and maybe it's a bumpy road. The infrastructure's not quite there, but it will get there, and I think it's a journey that's worth doing.
Yeah, absolutely. But there's a place for lots of different things. Solutions.
That's right.
So the non-carbon based fuels.
That's right.
There's a place for that too.
That's right.
And we need all the solutions we can get.
That's right. Yeah, I mean this Sonatas technology. We're in battery electric vehicles, combustion vehicles, hybrids, and everywhere in between. We're completely agnostic about that, but we're pro innovation, and we're excited to see so much innovation across the world.
And that's I can say the same thing about what I'm doing now.
That's great. Art, it's so great to talk with you. Thank you for joining us on the podcast and coming out to talk with us.
John, it's been great. Thank you very much. And keep it up. You're doing great.
Thanks so much. We hope you enjoyed today's episode live from Autotech Detroit. We look forward to seeing you again in another episode of The Garage very soon.